Hi guys, in this video we are going to work with question 6. We are still on Gauteng, grade 12, June 2023. This paper was written on the on June, yes, on June 2023, on the 9th June, yes, 9th June, if I'm not mistaken. Right, so we are focusing on question 6. We are going to look at question 6 today. So as we can see, guys, here we are given, this is a calculus, right? We are working with differentiation. But the first question requires that we find the derivative using the definition from first principles to calculate the derivative of f of x. Right, without wasting time, let's put this into practice. If you are new to this channel, what are you waiting for? Let's do the right thing by subscribing. You only subscribe once. Yes, let's work with question 6. So at question 6, we have 6.1 there. Remember that they wanted us to determine the derivative. Yes, remember that you were given the notation f of x is equals to 3x minus x squared. So we need to find the derivative of this using the first principle. Yes, using the first principle. So if we were to use a differentiation, finding this using a differentiation, we'll say the derivative of f of x. Remember that we are going to use what we call power rule. The power multiplies the coefficient here. 3 times 1 is going to be 3. Then 1 minus 1, it's going to be 0. X to the power 0, that's 1. Then 1 times 3, it's 3. Okay, so when you have to derive this squared, then we have a coefficient of negative 1. The coefficient multiplied by the power, that will be negative 2. You then subtract the power by 1. 2 minus 1, that's going to be 1. So x to the power 1, it's x. So this will be our solution using the differentiation. But they wanted us to use the definition from first principles. So we know the derivative of this. So we are going to say limit as h approaches 0. So it's going to be f of x plus h minus the given function divided by h. Okay, so let's go limit as h approaches 0. Guys, it means where you see x, you're going to replace it by x plus h. So we are going to say x plus h. Where there is x, replaced by x plus h. Okay, minus the given, don't forget to include the given function, which is 3x minus x squared. Okay, be very careful of your signs. That's why it's very important to put the brackets there. Right, divided by h. Let's go limit as h approaches 0. So now we will work out this by multiplying out. So when we say 3x multiplied by x, we get 3x, and 3 multiplied by h, we get 3h, right? So after that, we will square the first there. So it's going to be x squared. Then this power multiplies everything that is inside the bracket. So it's going to be 2 times x times h. Then we're going to have 2xh. Square the last there. That will be h squared. Okay. Are we still together? Yeah. Then this negative multiplies everything that is inside the brackets. Negative multiplied by 3x, that's negative 3x, and negative multiplied by negative x squared, we are going to have positive x squared. Okay, right. So now it's to work out with the like terms, guys. It's to work out limit as h approaches 0. So it's going to be 3x plus 3h. Remember, this is negative x squared minus 2xh. Remember, the negative affects everything here. So minus h squared minus 3x plus x squared. It affects this expression that is inside the bracket, divided by h there. Limit as h approaches 0. So let's work it out now. 3x and 3x will cancel each other because 3x minus 3x, that's 0. Do we have anything that can cancel each other? Yes, we have x squared, and negative x squared plus x squared, that's 0. So this goes as well. So what are we left with? We are left with 3h minus 2xh minus h squared. Is there anything that we are left with? Guess there's nothing that we are left with. We are left with 3h minus 2xh minus h squared divided by h. From here, you are going to look for the highest common factor. It's very important to look for the highest common factor. So the highest common factor is h. We are left with 3 minus 2x. Then here we are left with h, because remember h times h is it's h squared. So divided by h here. This goes, cancel each other. We are left with this limit as h approaches 0. So we are left with 3x minus, all right, 3, sorry for that. Where is that 3x coming from? It's 3 minus 2x minus h. Guys, what is interesting is that when we are here, remember that now we are going to, where there is h, we are going to place 0. So I'm going to have 3 minus 2x minus 0. So we know that 3 minus 2x minus 0 is still 3x minus 2x. So the solution here in this case should be 3 sorry for that, 3 minus 2x. Just as we have predicted on our first part, as we saw there. So we were right that the solution should be 3 minus 2x, right? So that is 6.1, guys. So let's go to 6.2. At 6.2, remember that was 4 marks. So 6.2 consists of 8 marks. So we are supposed to determine the derivative dy in terms of dy all over dx. So let's put this into practice. Right, okay, let's work it out. At 6.2.1, we are given, guys, y is equals to x minus root 3 root x, right? So divided by x squared. So this is interesting, guys. What is interesting here is that you need to change this into an exponential form. The root, we change it to exponential form. So it's going to be x 3. Then remember that you change it by half. So it's going to be x to the power of half divided by x squared. Then let's wake up. We haven't drive. We just have to change first. Let's fix this. So because there's a minus, we can separate this fraction. So it's going to be x divided by x squared minus 3x to the power of half divided by x squared. Okay. So now remember that we are applying the laws of exponents. Remember when you have a divided by m as well as a to the power of n, remember that when the bases are the same, you subtract the exponent. So that's the law that will apply even here. So we are going to have, when you divide here, we are actually going to have the bases are the same, then we subtract, we have power of 1 here. So in other words, it's going to be 1 minus 2, which is negative 1. Okay, then let's work it out. Let's work out this part. So we have this is, you're going to have 3 as well as half minus 2, half minus 2. Okay, all right, let's fix this. All right, let's work out this. So we are going to have x to the power of negative 1, 3x. Then when you say half, guys, minus 2, what are we going to have? We're going to have negative 3 all over 2. Now we need to derive dy all over dx. So when we derive, remember there's a power here. There's a coefficient. 1 times negative 1, that's going to be negative 1. Negative 1 minus 1, that's going to be negative 2. So from this part, we need to derive this part again. Negative 3 multiplied by negative 3 all over 2. Yes. Let's see what are we getting. Negative 3 times negative 3 all over 2. What are we getting? 9 all over 2. So we are getting positive 9 all over 2. Right, then you need to subtract this. Subtract negative 3 all over 2 by 1. you're going to have negative 5 all over 2. Negative 5 all over 2. So let's write this. So this will be, okay, let's say they wanted us to leave it in a positive form. We will say 1 all over x squared. In this case, it's going to be negative 1 all over x squared plus 9 all over 2. Let's multiply by this 1 all over x to the power of 5 all over 2. So let me write the final answer here. It will be negative 1 all over x squared plus 9 times 1, that will be 9. Then 2 times x to the power of 5 all over 2 as our solution in this case. So remember the set we in terms of dy all over dx. Don't forget that, guys. So that's very important to take note. So hope, guys, you saw what is happening at 6.2.1. Now we are going to deal with 6.2.2. 6.2.2, they wanted us to derive this, but we're given y divided by 3 all over x, and which is equals to 1 plus x to the power of 2. So I guess, guys, even not, let not guess, we know what to do is to make y the subject of the formula in this case, right? Okay, all right, let's do this. So we are going to do 6.2, but we are going to work with 6.2.2, right, which is also nice to do. So we are given y all over 3x, which is equals to 1 plus x squared plus x to the power of 2. So what is important here, let's just divide this by 1 so that we can make y the subject. So we are just going to cross multiply everything in this case. So if I cross multiply, I'm going to have 3x as well as 1 plus x to the power of 2, as well as y times 1 is going to be y. So let me write it like this: y is equals to, then let's expand this, or let's simplify this. 1 squared is going to be 1, okay, then 2 times 1 times x, that will be 2x, then square the last, that will be x squared. Then let's multiply it back. Okay, we are having 3x times 1, that's going to be 3. 3 times, that's going to be 3. 3x times 1, that's going to be 3. And 6 times 3 times 2x, that will be 6x squared, as well as 3x multiplied by x squared, that will be 3x cubed. So let's rearrange this. We have 3x cubed plus 6x squared plus 3x in this case. So let's derive dy all over dx. This 3 times 3, that's going to be 9, and 3 minus 1, that's going to be 2. So it's going to be 9x squared. 6 times 2, that's going to be 12x, because 2 minus 1, it's 1. Then here we have the power. Remember, 3 times 1, we're using a power rule. 3 times 1, it's 3. Then 1 minus 1 is 0. Then x to the power of 0 is 0. 3 times 1, 3 times remember, it's x to the power 0. Then x to the power 0 is 1. 3 times 1 is 3. Then we already done with this. There's nothing we can do from this part, right? I guess we are fine. Right, so let's go to 6.3. A function is given by h of x, which is equals to ax squared plus b of x, and has a minimum value of 12 if x is equals to 2. Calculate the values of a and b. Right, guys, this question is not that difficult. What you need to do is to challenge it. Remember, this is ax squared. That's a parabola. It's a second degree equation, so it's a parabola. So it's a parabola, but it's a smiling curve. How do we see that? Because of the values, because the minimum value is 12, and we are also given the x value, which is 2. So that's the x turning point. So I will advise that let us use this draw. Let's draw this. let's draw this. Okay, so it will be 2 and 12. Remember, 12 is our minimum value, and hence x is our x value. So what we could do, remember they wanted the values of x, of a and b. So we will work out, since we're having two missing variables. When you're having two missing variables, you are going to use a simultaneous equation. Remember, two variables, simultaneous equation. So let's write this. We are having h of x, which is equals to ax squared plus b all of divided by x. Remember that we have 2 and 12. Let's substitute this. Where there is h of x, we are going to place 12, and where there is a, we are x, we are going to place 2. So we are going to have b all over 2. So it's going to be 12 here. 2 squared, so that's going to be 4a. Then plus, this is the same as having 1 here, the coefficient of 1. 1 divided by 2 is the same as having half, right? So we need to make one of these the subject, but let's make a the subject. Let's take b to the other side. Let's take b to the other side. So it's going to be 12 minus, change the sign. It's going to be 12 minus half b, which is equals to 4a. So we could divide every side by both sides by 4. So when you say 12 divided by 4, what are you getting there? You are getting 3. You're getting 3. So what about half? Let's just say half divided by 3. What are we getting there? Oh, when you say 12, 12 divided by 4, that will be 3, and half divided by 4, what is that? That's 1 over 8. So we are going to have 1 over 8 b, which is equals to a in this case. So that's the first equation. You name that the first equation. So let's proceed and work out the second equation. To work out the second equation, remember they said the function is given as by h of x, which is equals to ax squared, has a minimum value. So since it has a minimum value, that's the first derivative. This happens where h of x is equal to 0. So what are we going to do? We are going to, let's fix this first so that we can derive. So we have ax squared, but the problem is this. Let's fix this. So we have it's gonna be b divided by 1 is gonna be b, so it changes the sign. When we change to exponential form, we are going to have bx to the power of -1. So remember, this happens when h of 2 is equals to 0. The derivative of h of 2 is equals to 0. Yes, it should be like this. So meaning that what we are going to do, where there is h of x, we can place 0 in this case. So let's derive. A times 2, it's going to be 2a, and 2 minus 1 is going to be 1. So we are going to have ax here. So b times -1 is going to be negative b, then -1 minus 1 is going to be -2. All right, so this is the derivative of us. This is the derivative. So we have 2ax. So we could leave this in a right, so let's work it out. Something missing here. So we have b times 1 all over x squared. If you change it to positive exponential, positive